Question 7, solve the equation cot equals sine x. So we're going to have to use a couple of identities. Also note that this is in degrees that they want in your final answer, so we should be noting that as we're starting. So you'll want to be checking that your calculator's in degrees and so on. So first of all, cot, we can sort of say, well, cot is the same as 1 over tan x, that equals sine x. Now tan is sine over cos, which means that cot is the same as cos over sine. So we can end up replacing that with cos x over sine x equals sine x. What we can now do is we can multiply through by sine x, so we end up with cos x equals sine squared x. Now at this stage we're dealing with sine and we're dealing with cos, so we're going to have to try and replace one of these. Now remember that one of our other identities is sine squared x plus cos squared x is equal to 1, which means that sine squared x is equal to 1 minus cos squared x. So what we can do is we can sub that into there. So we end up getting, and I'm just going to take, actually I'll just do it one time. So we end up with cos x equals 1 minus cos squared x. And what you can start to see is that we're starting to create a quadratic here. And some of you got as far as this as cos squared x plus cos x minus 1 equals 0. So we now need to factorise this, and we could factorise this by using the quadratic formula, or we can do a replacement if we need to, or you can just use your calculator. So we could just say x squared plus x minus 1, and then just see what the solutions that you end up getting out from there. Now, if you end up putting that in your calculator, what we will end up getting is, so if you make the replacement, you'll end up getting your x value. So what we need to do is cos to the minus 1 of the answer that you end up getting from your x value. So we end up getting, if we put that in, we get minus 1 plus root 5 all over 2. And again, if you're not sure where I've gone from there to there, it's about using the quadratic formula, or you can just pop it in your calculator. And that'll end up getting the answer 51.8 degrees. And because the range is within 360 and we're looking at cos, then if we think about our cast diagram, then it's also going to be 360 minus the 51.8, so we also get 308.2 degrees, and that would be the other answer.